Titration of potassium dichromate solution with acidified Mohs salt solution using diphenylamine as indicator. The number of moles of Mohs salt required per mole of dichromate is A3, B4, C5 or D6. Now let's look how the reaction takes place. 6 Fe2 plus Cr2 O7 2 minus plus 14 H plus gives 6 Fe3 plus 2Cr3 plus 7H2O. Now here the more salt, which is FeSO4 dot NH4 twice SO4 dot 6H2O and dichromate reacts in the ratio molar ratio of 6:1 as given in the equation. Therefore here the correct answer will be option D, 6:1. Alkaline medium CiO2 oxidizes H2O2 in O2 and reduces itself in C2 chlorine minus. Then how many moles of H2O2 will be oxidized by 1 mole of CiO2? Here are the options. Now let's look at the reaction. Now CiO2 oxidizes to chlorine minus. Therefore CiO2 plus 2H2O plus 5E oxidizes to chlorine minus plus 4OH. Now H2O2 gets reduced to H2O by this reaction. H2O2 plus 2H minus gives O2 plus 2H2O plus 2E. So now let's simultaneously solve both these equations to find out the answer. Now on solving these equations, we get the answer as 2CiO2 will be equal to 5H2O2. Therefore CiO2 will be equal to 2.5 H2O2. Therefore for oxidizing 2.5 moles of H2O2, 1 mole of CiO2 is required. Therefore the correct answer will be option C. Product of oxidation of I minus with MnO4 minus in alkaline medium is either A IO3 minus, I2 IO minus or D IO4 minus. Now let's look how the reaction takes place. MnO4 minus plus I minus in the alkaline medium, which is 6OH minus, gives rise to the products which is known as 6MnO4 2 minus plus IO3 minus plus 3H2O. Therefore the product form is IO3 minus, which is option A. The equivalent weight of KiO3 in the reaction 2CrOH3 plus 44OH minus plus KiO3 gives 2CrO4 2 minus plus 5H2O plus Ki is either A, the molecular weight, B, molecular weight upon 6, C, molecular weight upon 2 and D, molecular weight upon 3. Now let's find the oxidation number of KiO3 in this reaction. Let the oxidation number of K be X, since we don't know. Therefore K plus 1 minus, since this is O2 minus, we get as minus 2 into 3 is equal to 0. X plus 1 minus 6 is equal to 0. Therefore X will be equal to 5. Therefore the effective oxidation number is 5. Therefore the molecular weight will be equivalent weight will be molecular weight upon 6. Therefore the correct answer will be option B. Has the lowest oxidation number in A H2SO3, B SO2, C H2SO4 or D H2S. Now let the oxidation number of sulfur be equal to X. Therefore in H2SO4, 2 plus X minus, in H2SO3, sorry, with the first option, 2 plus X minus 6 equal to 0. Therefore X will be equal to plus 4. Now in SO2, X minus 4 is equal to 0. Therefore X will be plus 4 again. Now in H2SO4, that is option C, 2 plus X minus 8 is equal to 0. Therefore X is equal to plus 6. And in H2S, the oxidation number is 2 plus X, which is equal to 0, which is X equal to minus 2. Therefore the lowest oxidation number will be in H2S, which is option D. Oxidation number of nitrogen in NH2OH is A plus 1, B minus 1, C minus 3 or D minus 2. Now let the oxidation number of nitrogen be X here. Therefore in NH2OH, X plus 2 into the oxidation number of hydrogen, which is plus 1, minus oxidation number of oxygen, which is 2, plus 1 again will be equal to 0. Therefore, x plus 2 minus 2 plus 1 is equal to 0. Therefore, x will be equal to minus 1. Therefore, here the correct answer will be option B, minus 1. The oxidation number of phosphorus in BaH2PO2 twice is A minus 1, B plus 1, C plus 2 or D plus 3. Now let's look at the compound given. It is BaH2PO2 twice, which on opening gives BaH4PO4. Therefore let the oxidation number of phosphorus be X. Therefore 2 plus 4 plus 2x minus 8 will be equal to 0. Therefore 2x is equal to 2. Therefore x is equal to plus 1. Therefore here the correct answer is option B, plus 1. Oxidation number and the electronic configuration of sulfur in H2SO4 is, here are the different options given. Now let's look at the compound H2SO4. Now let the oxidation number of sulfur here be X. Therefore 2 into plus 1, which is the oxidation number of hydrogen, plus X plus 4 into minus 2, which is the oxidation number of oxygen, is equal to 0. Therefore plus 2 plus X minus 8 equal to 0. Therefore X is equal to positive 6. So here the oxidation number is plus 6. Now the electronic configuration of H2SO4 is 1s2, 2s2, 2p6. Therefore here the correct answer is option D. Oxidation number of sulfur in Na2H2O3 is A plus 1, B plus 2, C plus 3 or D minus 3. Now let the oxidation number of sulfur in Na2H2O3 be X. Therefore 2 into the oxidation number of Na, which is plus 1, plus X plus 3 into the oxidation number of oxygen, which is minus 2, equal to 0. For 2 plus 2x minus 6 is equal to 0. Therefore 2x is equal to 4. Therefore x is equal to plus 2. Therefore the oxidation number of sulfur is plus 2, which is option B. The number of As atoms in H3AsO4 is A minus 3, B plus 4, C plus 6 or D plus 5. Now let the oxidation number of As be X here. So 3 into plus 1 plus X minus 2 into 4 will be equal to 0. Therefore X will be equal to 8 minus 3, which is equal to positive 5. Therefore here the correct answer will be option D, plus 5. In XeO3 and XeF6, the oxidation state of Xe is A plus 4, B plus 6, C plus 1 and D plus 3. Now let's look at the individual compounds in XeO3. Now let the oxidation number of Xe be X in both the cases. Therefore X plus 3 into the oxidation number of oxygen, which is minus 2, equal to 0. Therefore X minus 6 equal to 0. Therefore X is equal to plus 6. And in XeF6, X minus the oxidation number of F, which is 6, equal to 0. Therefore X is equal to plus 6. Therefore in both the compounds the oxidation number of Xeon Xe is plus 6, which is option B. Oxidation number of Fe and sulfur in iron pyrites are A 4 minus 2, B 2 minus 1, C 3 minus 1.5 and D 3 minus 1. Now the formula for iron pyrites is FeS2. Now first let's find out the oxidation number of Fe. Let that be as X. Therefore X minus 4 is equal to 0. For X is equal to plus 4. Now therefore the oxidation number of iron is 4. Now let's find out the oxidation number of S. So let that be as X. Therefore 4 plus 2x is equal to 0. Therefore 2x is equal to minus 4. For x is equal to minus 2. Therefore the oxidation number of Fe is 4 and S is minus 2, which is option A. Oxidation number of nitrogen in NO3 minus is A minus 1, B plus 2, C plus 3 or D plus 5. Now let the oxidation number of nitrogen be X in this compound. Therefore X plus 3 into minus 2, which is the oxidation number of oxygen, which is equal to minus 1 since the charge here is minus. Therefore, x minus 6 is equal to minus 1. Therefore, x is equal to plus 5. Therefore, the correct answer is option D. Number of iodine in IO3 minus, IO4 minus, and Ki and I2 respectively are. Here are the options. Now, let's find the oxidation number of iodine. Let the oxidation number of iodine in all these compounds be x. Therefore, in first, which is IO3 minus, x plus 3 into minus 2 is equal to minus 1 since there is a negative charge here. Therefore, x minus 6 is equal to 1. Therefore, x is equal to 5. Now, in IO4 minus, x plus 4 into minus 2 is equal to minus 1. Therefore, x minus 8 is equal to minus 1. Therefore, x is equal to 7. Now, in Ki, it is x 1, which is the oxidation number of potassium K, plus x is equal to 0. Therefore, x is equal to minus 1. And in iodine, which is I2, it is 2x is equal to 0, and therefore x is equal to 0. Therefore, the correct answer is C, which is plus 5, plus 7, minus 1, and 0. Is A in the following reaction. 2Fe3 plus SN2 plus gives 2Fe2 plus A. Is it SN3 plus, SN4 plus, SN2 plus, or just SN? Now let's look at what the reaction is happening place. 2Fe3 plus SN2 plus gives, now the first product is 2Fe2 plus, hence Fe3 plus is going and undergoing a reduction to form Fe2 plus. Hence this reaction is redox reaction. In redox reaction, a reduction and oxidation takes place. Therefore, SN2 plus will get oxidized to SN4 plus. Therefore the A will have a value SN4 plus, which is option B. Which of the following is the strongest oxidizing agent? Either it is A, BrO3 minus, or Br2 plus, which has oxidizing potential of plus 1.50, or B, Fe3 plus and Fe2 plus, which has an oxidation potential of 0.76, or C, MnO4 minus or Mn2 plus, which has an oxidation potential to 1.52, or D, Cr2O7 2 minus or Cr3 plus, which has an oxidation potential of 1.33. Now we know that higher is the reduction potential, therefore stronger will be the oxidizing agent. Therefore, out of all the four, in option C, MnO4 minus Mn2 plus has a reduction potential of plus 1.52, which is more than any of the other options. Therefore, the correct answer is option C. Balanced chemical reaction. This is the reaction. A, B, C, and D respectively corresponds to. Here are the different options. Now let's look at what the reaction is, how the reaction is taking place. IO3 minus plus AI minus plus B H plus gives C H2O plus D I2. Here I minus undergoes reduction to form I2, and IO3 minus undergoes reduction to form I2. So here I minus undergoes oxidation to form I2, and I03 minus undergoes reduction. Now let's look at how the reduction is taking place. So 2IO3 minus plus 12H positive, and it requires 10 electrons for the reduction to take place. Hence the product is I2 plus 6H2O. And let's look how the oxidation takes place. It's 2I minus, which is I2 plus 2E minus. Now we have to compare these both equations. So the 10E must be cancelled. Therefore we have to multiply this by 5. On multiplying by 5, we get the answer as IO3 minus plus 5I minus plus 6H plus gives 3I2 plus 3H2O. Therefore, on comparing this with the given equation, the values are A is 5, B is 6, C is 3, and D is 3, which corresponds to the option A. So the correct answer is option A. Equation H2S plus 2HNO3 plus 2H gives 2H2O plus 2NO2 plus S. The equivalent weight of hydrogen sulfide is 16, 68, 34, or 17. Now let's look what happens to hydrogen sulfide in this reaction. It undergoes a reaction and forms only sulfide plus 2 electron atoms, which gets evolved. Now, therefore, the equivalent weight will be equal to the molecular weight of sulfide upon the number of electrons, which is 2. Therefore, 34 upon 2, which is equal to 17. Therefore, here the correct answer is option D, 17. The four oxyacids and chlorine, the strongest oxidizing agent in dilute aqueous solution is A. HClO4, B. HClO3, C. HClO2, and D. HOCl. Now, out of the four answers given, in HClO4, the oxidation number of Cl is equal to +7. Hence, it is the strongest oxidizing agent. The oxidizing agent is strongest when its oxidation number is highest. The correct order out of the four will be HClIO, which is less stronger than HClO2, which is less stronger than HClO3, which is less stronger than HClO4. Therefore, here the correct answer is option A, HClO4. In the reaction Ag2O plus H2O2 gives 2Ag plus H2O plus O2, the H2O2 acts as option A, reducing agent, option B, oxidizing agent, option C, bleaching agent, or option D, none of the above. Now let's look at what is happening in the reaction. Now Ag2O plus H2O2 gives 2Ag plus H2O plus O2. Now here Ag2O undergoes reduction and hence forms Ag, and subsequently H2O2 undergoes oxidation to form H2O. Therefore here H2O2 acts as a reducing agent, which is option A. Oxidation state of phosphorus in cyclotriametaphosphoric acid is A plus 3, B plus 5, C minus 3, D plus 2, or E minus 2. Now, the formula for cyclotrimethaphosphoric acid is HPO3 thrice, the whole thing thrice. Therefore, the oxidation state of P will be, let that be equal to X. Therefore, the oxidation state of P is 3 into plus 1, which is the oxidation state of H, plus X plus 3 into minus 2, which is the oxidation state of oxygen, is equal to 0. Therefore, X minus 6 plus 1 is equal to 0. For X is equal to plus 5. Therefore, here the correct answer is option B. The oxidation state of chlorine in perchloric acid is A minus 1, B 0, C minus 7, or D plus 7. Now the formula for perchloro acid is HClO4. Therefore, let the oxidation state of chlorine be X. Therefore, plus 1, which is the oxidation state of hydrogen, plus X plus 4 into minus 2, which is the oxidation state of oxygen, is equal to 0. Therefore, 1 plus X minus 8, therefore, is equal to 0. Therefore, X is equal to plus 7. Here, the correct answer is option D, plus 7. MnO4 is reduced with oxalic acid in acidic solution. The oxidation number of Mn changes from, here are the different options. Now let's look at how the reaction takes place. Oxalic acid COOH plus 2 KMnO4 plus 3H2SO4 gives the answer as K2SO4 plus 2 MnSO4 plus 10 CO2 plus 8H2O. Now in this reaction, the oxidation state of Mn changes from plus 7, which is here, to plus 2, which is here. Therefore, the correct answer is option C, 7 to 2. Oxidation state of chromium in the final product formed by the reaction between Ki and acidified potassium dichromate solution is A plus 4, B plus 6, C plus 2, and D plus 3. Now let's look at the reaction between Ki and acidified potassium dichromate. Therefore, K2Cr2O7, which is potassium dichromate, plus 6Ki plus 7H2SO4 gives the answer as K2SO4. 4K2SO4 plus Cr2SO4 thrice plus 7H2O plus 3I2. Now we need to find the oxidation state of chromium. So Cr2SO4 thrice decomposes to form 2Cr plus 3SO4 2 minus. Therefore, chromium here has an oxidation state of plus 3. And here the correct answer is option D. So the following compounds nitrogen exhibits highest oxidation state: A N2H4, B NH3, C N3H, or D NH2OH. Now let's look at all the compounds and the oxidation states. Compound and oxidation number of nitrogen. Now in N2H4 the oxidation number of nitrogen is -2. In NH3 the oxidation number of nitrogen is -3. In N3H the oxidation number of nitrogen is minus 1 by 3, and in NH2OH the oxidation number of nitrogen is -1. Therefore nitrogen exhibits highest oxidation state in option C, which is -1 by 3, which is the correct answer. This is the given reaction: C2H6 plus NO2 gives CO2 plus H2O. In this equation, the ratio of the coefficients of CO2 and H2O is A 1:1, B 2:3, C 3:2, and D 1:3. Now here the given equation is not balanced. Hence, to balance the equations, the balanced equation is C2H6 twice plus 7O2 gives 4CO2 plus 6H2O. Therefore, the ratio of the coefficients of CO2 and H2O is 4:6, which is equal to 2/3. The correct answer here is option B. The electrons involved in the reduction of Cr2O7 2- in acidic solution to Cr3 plus is A0, D2, C3, and D5. Now, let's look at the reduction of Cr2O7 to Cr3 plus, which is as follows: Cr2O7 2- plus 3E negative gives Cr3 plus. Therefore, this undergoes reduction. In this reduction, 3 electrons are required for the reduction of Cr2O7 to Cr3 plus. The correct answer here is therefore option C. Moles of Cr2O7 can be reduced by 1 mole of SN2 plus. A 1 by 3, B 1 by 6, C 2 by 3, and D 1. Now let's look at the reaction where CrO7 is reduced to Cr3 plus using SN2 plus. Therefore Cr2O7 2- plus 14H plus 3SN2 plus gives 3SN4 plus 2 Cr3 plus 7H2O. This is the reduction where Cr2O7 gets reduced to Cr3 plus using SN2 plus. Hence, it is clear from this equation that 3 moles of SN2 plus is required to reduce 1 mole of Cr2O7. Hence, 1 mole of SN2 plus will be required to reduce 1/3 moles of Cr2O7 2-. Therefore, the correct answer here is option A 1 by 3. Number of S in S2Cl2 is A plus 1, B minus 1, C plus 6, or D 0. Now let the oxidation number of S in S2Cl2 be X. Therefore, 2x plus 2 into -1, which is the oxidation number of chlorine, is equal to 0. Therefore, 2x minus 2 is equal to 0 and x is equal to plus 1. The correct answer here is option A plus 1. The oxidation number of sulfur in Na2S4O6. Either it is A 2 by 3, B 3 by 2, C 3 by 5, and D 5 by 2. Now let's let the oxidation number of sulfur be X here. Therefore 2 plus 4x minus 12 is equal to 0. 4x is equal to 10 and x is equal to 10 by 4, which is 5 by 2. Therefore, the correct answer here is option D 5 by 2.